Welcome to this explainer. Listen, today we are focusing entirely on you, the preschool educators. We're going to explore a truly practical, empowering guide to help you translate early math concepts directly into play-based classroom activities. Now, we all know that navigating a room full of 4-year-olds can sometimes feel like, well, beautiful, organized chaos, right? But today, we're taking the high-level theory of early childhood education and turning it into something you can literally use the second you walk into your classroom. So if you want to know exactly how to spark a genuine love for numbers and logic in the minds of our youngest learners, right amidst all the paint and the building blocks, you are absolutely in the right place. Let's get started. Okay, let's dive into this. What does math actually look like at age 4? For a long time, people just pictured flashcards, boring worksheets, maybe some rote memorization. But we need to challenge that idea right here, right now. At 4 years old, math isn't about sitting quietly at a desk. No way. It is loud, it is messy, and it is entirely intertwined with play. Early math is really just a natural extension of how children interact with the physical world around them. To get us there, here's our pillar to practice roadmap. Number 1, rethinking early mathematics. 2, core mathematical concepts. 3, fostering logical thinking. 4, solving problems through play. And finally, number 5, the teacher's role. All right, section 1, rethinking early mathematics. This whole section is really about making early childhood mathematics hands-on, meaningful, and deeply connected to real-life experiences. Let's look at this foundational definition. Early mathematics refers to the basic mathematical concepts young children develop through daily play, routines, and exploration. Now, the main word I really want you to take away from this is daily. Math isn't just something that happens during a designated, rigid 15-minute lesson block. It happens organically. It's happening when they're pouring water at the sensory table. It's happening when they're lining up for recess and when they're sorting their snacks. The math is already happening. Our job is just to recognize it. Moving right along, section 2, core mathematical concepts. Let's identify the specific mathematical foundations young learners actually need to develop. The absolute key building blocks here are counting and number sense, patterns and shapes, measurement, sorting and comparing, and spatial awareness. As educators, these are our main targets. But remember, children are naturally exploring these exact concepts every single day. Think about it. When a kid tries to cram a giant toy into a tiny box, what is that? That's spatial awareness. When they suddenly notice that their best friend got way more crackers than they did, boom, that is number sense and comparing in action. And this brilliantly illustrates exactly how we map those concepts directly to practical classroom activities. If we want to teach measurement, we don't necessarily need to pull out a ruler. We just need to have the kids compare the heights of the block towers they just built. Simple, right? For sorting, we can just ask them to organize a giant bin of mixed blocks by color. And for patterns, stringing beads and predicting whether that next bead should be red or blue is absolutely perfect. Honestly, this is what the theory looks like in action. Okay, section 3, fostering logical thinking. Logical thinking and reasoning is defined as the ability to make sense of information, identify relationships, compare ideas, and explain why something happens. And wow, this is a massive cognitive leap for them. This is that absolutely crucial moment when children start to look beyond just what they're doing and begin to genuinely understand the why and the how behind their play. It's like watching a giant puzzle come together. They are finally connecting the dots. So, how do we spot this reasoning developing in real time? Well, children naturally practice these skills when they sort objects, recognize patterns, predict outcomes, classify items, and, most importantly, explain their thinking. I highly encourage you to really look out for these specific behaviors during unstructured playtime. When a child says something like, "Hey, the car won't roll because the rug is bumpy." They are literally identifying relationships and explaining their reasoning. That is pure logical thinking happening right there in the playroom. But how do we, as teachers, actively nurture this? Well, our support translates to classroom application in 3 key ways. First up, through games and puzzles, we're finding that one missing piece requires real spatial reasoning. Second, we can offer open-ended activities, like building massive structures out of recycled materials without any instructions whatsoever, forcing them to test and adapt. And crucially, third, we can use questioning. Simply pausing for a second and asking, what do you think happens next? Instantly activates their predictive reasoning. Which brings us to section 4, solving problems through play. So the crucial point here is that problem solving helps children think of completely different ways to tackle challenges. I really want to remind everyone that early problem solving is not about worksheets or timed tests. Not at all. It's about creatively navigating the physical world and their social interactions. It's really just about encountering an obstacle right in the middle of their play and figuring out a clever workaround. Let's visualize this happening in your classroom right now. Problem solving happens when kids are carefully counting out crayons to ensure everyone at their little table has enough. It happens when they're desperately trying to share materials equally so a disagreement doesn't break out. It's happening when they're building a massive block structure and trying to figure out exactly why it keeps falling over, adjusting the balance over and over until it finally stands. It happens when they're completing complex patterns or systematically hunting down a missing toy. You see, these are profound mathematical challenges, just cleverly disguised as everyday preschool life. And finally, Section 5, the teacher's role. Now, what's really interesting about this slide is that it requires a major pedagogical shift because your facilitation style literally dictates the success of these play-based strategies. The traditional approach often involves the teacher just giving the correct answer the second a child gets stuck. But the recommended approach, it flips this completely upside down. Instead of just supplying the answer, we should be actively encouraging children to try, to think, to discuss, and to reflect. It's a huge shift from passive instruction to active, patient facilitation. So when that block tower falls over, don't just fix it for them. Ask them why they think it fell. Guide their reflection. So I'll leave you with this. Next time a child builds a tower in your classroom, what mathematical questions will you ask them? Will you ask about the shapes of the blocks, the overall height, the balance, the number of pieces? The math is already there. It's just waiting in the play. And your questions? Well, they're the key that unlocks the whole thing. Take these strategies, step into your classroom tomorrow, and start exploring the math that is already happening all around you. Thank you so much for joining me for this explainer.